Mr. Dunson's median was a little bit trickier. If you'll remember, Mr. Dunson's median was actually right here. And I told you that neither 81 nor 88 was actually the median. And that's because the median would be somewhere in between them since there was not just one number in the middle. So when I create a lower half, because 81 was not actually the median, it will be included in the lower half. And because 88 was not actually the median, it will be included in the upper half. Then I'm going to do the same thing, which is to find the mean of, or the median of both sets of data. So I'm going to take one from the front, so 64, and one from the back. So 64 and 81. Then 73 and 79. Well, you'll notice at this point we have two numbers in the middle. And remember, if I'm finding the median of two numbers and I have two numbers in the middle, I have to add them together. So I'll do 74 plus 77, then divide by 2. Well, if I do 74 plus 77, I'm going to get 151, and I'm going to do 151 divided by 2, which gives me 75.5. So my first quartile is 75.5. My upper quartile or third quartile is going to come from my upper half. So I'm going to take one from the front and back, and then I'm left with two numbers in the middle. So I'm going to add them together, 93 plus 96, then divide by 2. 93 plus 96 gives me 189. So I'm going to do 189 divided by 2. When I get 189 divided by 2, I get 94.5. So my third quartile is 94.5. So to find the interquartile range, I'm going to subtract those from each other. 94.5 minus 75.5. When I subtract those, I get 19. So this means that Mr. Dunson has an interquartile range of 19. The interquartile range really describes the center of your data set and how spread apart the center of your data set is. So since Ms. Jackson has a smaller interquartile range, I know that hers is less spread out. And again, that tells us that her data set is more consistent, which means that it is more easy to predict. So the conclusion that I'm going to come to here is that Mr. Dunson's IQR is greater than Ms. Jackson's, and this means that his data is more spread out, which means that it is not as consistent as Ms. Jackson's. Now let's look at the number of students or siblings that students in each class have. You have students for Miss Yolanda and Mr. Tate. The first thing you need to do, once again, is order your data sets from least to greatest. Check your data sets with these. Miss Yolanda should be 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 3, 4, 5, 7, 8. Mr. Tate should be 0, 0, 1, 1, 1, 1, 2, 2, 2, 3, 3, 3, 3, 3, 4, 5, 5. The first question asks how many students are in each teacher's class. If you count, Miss Yolanda has 15 students in her class, and Mr. Tate has 17 students in his class. These numbers do include the zeros because 0 represents a student in the class. It represents a student who has 0 siblings. Number 2 asks what is the range of the number of siblings in both classes, and then make a conclusion about that. So again, range is found by subtracting the greatest from minus the least. So for Miss Yolanda, her greatest is 8 and her least is 0. So I'm going to do 8 minus 0, gives me 8. For Mr. Tate, his greatest is 5 and his least 0, so we're going to do 5 plus 0, which gives us 5. Remember that range is a measure of spread, which means that it tells us how consistent a data set is. Since Mr. Tate's range is 5, that means his data is less spread out than Ms. Yolanda's because hers is 8. So I can say that Mr. Tate's data set is more consistent than Ms. Yolanda's. And so to the right, the number of siblings is more consistent for his students. Number 3, what is the mean number of siblings in both classes in the two kids? Yolanda, I would add all of these numbers together. So I'm going to do 0 plus 0, 1 plus 1 plus 1 plus 1 2 plus 2 plus 2, 3 plus 4, 5 plus 7 plus 8. And then I put all of that in one big formula. And then remember, I need to divide. So again, we're dividing by the number of students because the number of items is 3 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we give 38 divided by 13. When we divide this, we get 2.5333 numbers of students. So we can write this as 2.53 with a bar and then a 3 for the students. From the table, we are again going to add all of those numbers. So 0 plus 0 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 3 plus 4 plus 5 plus 5. And we add all of those together to get 39. Again, we have to divide by the number of items in the data set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we're going to divide 39 and 7. When you do that, you'll notice that you get a number that is not actually repeated. So if you have a number that does not repeat like this one, 2, 9, 0, 1, 7, 6, 4, 7, I'm not going to write it. What I'm really going to do is round it to 9. Remember that the 9 is not a siblings. So we look at the number behind 9. If this number is less than 5, that tells you that we should use the 9 for the kids. So we round it to 2. And we're going to do it. Number 4, what is the median number of siblings in both classes and how do you compare? Since there's just that 1, 2 in the middle, that number is my median. We're going to do the same thing with Mr. Tate. A number from the front and then back. So then 0 and 5 again. 1 and 4. This 1 and 3. This 1 and this 3. This 1 and this 3. 2, 3, 2, 3. And you'll notice that you're left with 2 in the middle. So for this, Mr. Tate also has a median of 2. Well, since they both have a median of 2, you can't really make a comparison either way. So I'm going to say both classes have the same median number of siblings. Number 5, what is the mode number of siblings in both classes and how do these compare? Well, you'll notice for Miss Yolanda, there are several numbers that repeat. You have 0, which occurs 2 times. You have 1, which occurs 5 times, and you have 2, which occurs 3 times. Now, all of those are not the mode. The mode is which of these numbers occurs most. Well, since 1 occurs more times than all of them, I'm going to say that Miss Yolanda has a mode of 1. Now for Mr. Tate, we see the same sort of thing. 0 occurs twice, 1 occurs 4 times, 2 occurs 3 times, 3 occurs 5 times, and 5 occurs twice. Well, again, you have one number that occurs more than all of them, and that number is 3. So Mr. Tate is going to have a mode of 3. Since Mr. Tate's mode is larger, we would say he has a greater mode. So we are going to say Mr. Tate's class has a greater mode than Miss Yolanda's class. We don't usually use mode to describe anything about the data sets because it really doesn't tell us a lot about that data set. Number 6, based off the number of siblings, which measure would be most accurate estimate? Well, again, there is not an outlier in either data set, so I'm going to say that the mean would be the best measure of center to use since there is not an outlier. Number 7 asks, what is the interquartile range for each class and what does this tell us? Well, remember, to find interquartile range, the first thing we had to do was find the median. Well, we had already done that by taking one number from the front and one from the back until we got all the way down to the middle. So for Miss Yolanda's data set, we had found that the mode was 2, and more specifically, it was this 2. Now, by finding the median, I'm able to create a lower half of my data and an upper half of my data. I have to use that to find the median of each half. So for my lower half, I'm going to take a number from the front and back. So front and back, and you'll notice that I'm left with 1. So my first quartile here is 1. Then we're going to do the same thing with the upper half. 1 from the front and back, front and back, and we're left with 4. That means my third quartile is 4. So to find the interquartile range, I'm going to subtract those. 4 minus 1, which gives me 3. So Miss Yolanda has an interquartile range of 3. Now for Mr. Tate, when we found his median, we noticed that it was 2 also. But for Mr. Tate, it wasn't the first 2, it was actually the last 2. Now that split the data set into a lower half and an upper half. So we're going to find the median of each half. Well, 1 from the front and back, front and back, front and back. And then you'll notice we're left with 2 numbers in the middle. So when we have that, we have to add them together. So 1 plus 1, then divide by 2. Well, 1 plus 1 is 2, and 2 divided by 2 is 1. So Mr. Tate's first quartile is 1. Then we're going to do the same thing with our upper half. So front and back, front and back, front and back, and we're left with 3s in the middle. Well, again, we would add those together, divide by 2. 3 plus 3 is 6, and 6 divided by 2 is 3. So that means his third quartile is 3. To find the interquartile range, I'm going to take those numbers and subtract. So 3 minus 1 gives me 2, which means that Mr. Tate's interquartile range is 2. Since his interquartile range is smaller and interquartile range is a measure of spread, that means that his data is less spread out. That means that it is actually more consistent. So we are going to say Mr. Tate's class has a smaller interquartile range, which means the number of siblings is more consistent for his students.